Okay, hello and welcome everyone. It's been a couple weeks since we've been here. I hope you all had a great fall break. We've kind of been taking it easy in this class, at least for the last week or so. I know we've been moving along, but hasn't been anything too terribly stressful for you, I hope, at least in this class for the last couple weeks. I do want to kind of give you a heads up that we are going to be tackling some more challenging topics, though. So this week is definitely one of the trickier topics. And then next week, especially, is somewhat known for being one of the more difficult topics that we're going to cover in the class. So just kind of want to make you aware of that and give you a little piece of advice as we come into the second half of the semester. What we're talking about does build off of the concepts build off of one another. So for next week especially, if you're having trouble understanding what we're talking about, come back to this stuff and make sure you understand it very, 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 very well. I can assure you that if you do not understand the topic that we're talking about today, what we talk about next week is going to be extremely difficult. So if you find yourself in that position, take a step back, make sure you understand this stuff backwards and forwards before trying to move on with the rest of the material. This is some great stuff, some important stuff that we're going to be talking about today. Before I get into that, though, I just wanted to take a moment and see if anybody had any questions about the schedule or logistics. We don't really have much of notes coming up, but anybody has any questions? Okay. So let's go ahead and hop into it. Today's topic is a good one. We're going to be changing the way that we view our code quite a bit today. We're introducing something that's called methods. So every program that we've written up until today has started at the top, right, or ish, close, and then kind of worked its way down, left to right, somewhat like we're reading a book. And yeah, it's a lot different than English, but we're kind of getting used to figuring that stuff out. Today, we're actually going to be switching that up quite a bit and no longer starting at the top and working our way down, but having many different sections of our code called methods. And we're going to be able to jump from one of these methods to another, one section of our code to another whenever we need to. It might sound like this is going to make our programs more complicated. Might add some more things for us to keep track of, and that's true. It is going to make things a bit more complex for us. It is going to make things a little trickier to understand, and so that's my biggest goal for today, is to hopefully give you the tools, the skills that you need to analyze these programs now that we've got methods involved. But there's a big value, a big advantage to using them. We wouldn't introduce this complexity for no reason. So hopefully I'll illustrate that to you as well. Let's start by taking a look at a very, very simple example. And I'm actually, so you can see right up here at the top, we start things out a little bit differently. I'm used to seeing, actually, let me pause for just one moment and say that for those of you who would like to follow along, I'm on the song file in Module 5, exercises batch 2, just to make sure we're all on the same page. But yeah, up here at the top, I'm used to seeing, public static void main right here. And I see the beginning of that, and then they throw you a curveball, and it's not main anymore, but chorus. And actually, if you look down a little bit, here's main down here. And while I believe I've mentioned this to you maybe once or twice today, I think it becomes very important to remember the fact that this is the main method. So we've actually been using methods this whole time. We've been using one. We've been using main. Main is a method. It's the main method. Does anybody remember what the purpose of the main method is? What the main method does for us? It has a very specific role. Been using it a lot. Must do something for us, right? It's been a while since we talked about it, so it's okay if you don't recall. But the main method is the entry point of our program. That's important because we now have different sections of our program, right? So where do we start? We start at main. We always start at main. So what's the first line of code that's going to get executed? The first line of code that's going to get executed is the first line of code that I see inside of the main method, which is this line right here, line number 14. That's important because, as you can see in this file, main is not necessarily going to be at the top anymore, right? It might be. It might be all the way down at the bottom with a whole bunch of other stuff on top of it. Sorry about that. Speaking of static, oh my gosh, that's going to drive me crazy. It's got to stop. Okay. Oh boy. It's going to be a long, all right. Sorry. Can everybody hear me okay if I just yell really loud? Yeah? Okay, thank you. Yeah, let me know if you can't. So, where was I? Yeah, so this is the main method. If there's 100 methods in the file and you tell the computer to run the code, which one is it going to do first? It's going to look at them all and find main. Find the one called main. And that's where it's going to begin. So there's no ambiguity about where we start. We always start at the main method. That is the first method that always gets executed. So let's go ahead and walk through this program. I'm going to kind of introduce a lot of stuff in this very simple example, a lot of terms, some new vocab. But please holler at me if you need me to slow down and talk about anything in more detail. I have set a breakpoint here at line 14. So again, this is the very first part of our program. And if I start this in debug mode, you'll see that it pauses on line 14. And this line of code, we actually have a name for this. This is a method call. So it's a method call. I see the name of this method up here, followed by parentheses, just like it appears up top. So what this is saying, what this is telling the computer to do is to go find the method that is called chorus and do those things. And we're really starting to get into already why we like to use methods. Consider what this allows us to do. This allows us to reuse code and repeat a section of code over and over and over again. You might be saying to yourself, well, we could already do that, right? We have loops that allow us to do repetition, and you're correct. But I think the big advantage that methods provide to us that loops don't necessarily provide to us is that with methods, I can give this a name. I can give this behavior a name. And that's really what methods are on a human level. If you're trying to kind of make the computer idea of a method, mesh with what your human version of the world looks like, a method is just a set of behaviors that have been given a name. We actually use this idea quite frequently. A common example is cooking. So if any of you like to cook, I love to cook. I do all the cooking in my house. You're probably familiar with things like stirring and baking and sautéing. Those are cooking terms that have a very specific meaning, right? When I say the word sauté, that means something very specific. That's telling me to do something very specific within a recipe, right? But also keep in mind that I'm not stirring the same things every time, right? I'm not baking the same things every time. The recipe is telling me, all right, here's a behavior called stirring, and this time I want you to stir these two things together. And I do the same behavior but with different things. That's the same idea of a method, right? Allows us to apply a name to a certain set of behavior. And then furthermore, we can kind of tweak that behavior and reuse that behavior over and over again within our code. I'll try and illustrate that more as we go on. But let's return to the execution here. I think one thing that's important to notice with the debugger now that I haven't really paid a lot of attention to before is over here on the left side, we see something called the method call stack. So stack as in a stack of plates, right? It's the same idea. This is going to keep track of all of the method calls that we run across as we go through our code. So you can think of this as kind of a roadmap to where we've been within our code. And so right here on line 14 is a method call. It says, go do the stuff in the chorus section of the code. So I'm going to go up here and click on the arrow to do this. And actually, in a little bit, today is the day that I get to explain to you what the difference is between these two yellow arrows in the debugger. I'll come back to that in a moment. But for now, I'm going to click step into, and notice that we jumped up to line 8, right? So no longer am I just going top to bottom. Method call says, go up there and do that stuff. So here I am in line 8, and over here on the call stack, notice it says main at the bottom, and it says chorus on top of that, right? So I was in the main method. It told me to go to the chorus method, so that's where I am now. So whatever I see on the top of the call stack is where I am right now. That's the line that I'm doing right now. Anything that comes below that, that's how I got there. That's the path that I took to arrive at that particular position. It's a handy tool that we can use to track our progress through the program. We can continue to step through, and you'll see that as we step through the chorus method, it's going to spit out the lines from the chorus, right? Gets to the end of the method, so this chorus method is now over. It's done the behavior that we've asked it to do. So what's next? What am I going to do now? Well, the way that method calls work, once the method is over, we do what's called a return. We return from where we came from. And we can use the method call stack to help us with this. That's actually what the computer does. The method call stack says, all right, this one is over, so now I'm just going to return to wherever I was before. So where was I before? I was on the main method, line number 14. That's where I need to go back to now. And so when I click step one more time, you'll see that, okay, I did this. I went up there and I did that stuff. I came back once I was done, and now I'm going to proceed along with the rest of the code in the main method. Any questions about what I've done so far? That was our very first method call, our very first jump to somewhere else, and then return back. And that's what we're going to be doing all day today. So if we keep on going here, right, you can see that it prints out the last, or it prints out the other section of the song, and then we get down here to the bottom, and actually I see this is actually the chorus again. So these two lines are the same two lines that are up here in the chorus. I don't know this particular song very well, but I can see that those are identical. That's what choruses are, right? A section of a song that's repeated. But we're not making good use of our methods here. So having this line of code, these lines of code be repeated here is actually not a great idea. And you can see the instructions tell us to replace these two lines of code with a method call. And in this very simple example, that's as simple as taking those two lines of code and replacing them with the exact same method call that we had up here at the top. Because a method call says, go up and run this section of code, and then come back. So if I want to run the chorus once at the beginning of the song, and once at the end of the song, then I can just use two method calls, right? If you want to, stop the debugger and make that change and run it, you'll see that the chorus does, in fact, get printed out twice. And I think this is actually a great time to talk about why we really like to use methods, at least one reason why we really like to use methods. Consider a song where the chorus shows up a whole bunch of times, 5 times, 10 times. And if we didn't have methods, what would we do? We would probably do kind of like what we see here, where I've got the lyrics typed out, and if I'm not using methods, then the option that I have is to copy paste, right? Just copy paste the chunk anywhere that I need the chorus to appear. Well, consider that what if I have a typo, and then everywhere I need the chorus, I grab this chunk of code because that's the chorus, and then I just paste it in a bunch of times. Well, now I've pasted in the typo as well, right? I've taken that mistake and copied it. That's a bad thing. That's not a good thing. Consider the alternative. If I had used a method instead, it does kind of increase the complexity. I'm now jumping around all over the place, but think about what that means. These two lines only show up in one spot. They show up right here. So if I make a mistake, I don't have to go find all 10 places where I copy and pasted that mistake. I have to go to the one place where I made that mistake and fix it. Or it doesn't even have to be a mistake, right? Let's say that You know, I think this song would sound better if I changed the words a little bit. If I've copy pasted the words 10 times, then I got to go visit each of those 10 spots and change the words in each of those 10 spots. But if I've got this chorus repeated as a method, then any changes that I make here, right, change the word before to after, for example, any changes that I make here are going to show up anywhere that I call this method. Do you see that? It's a very powerful concept, right? One change to this method is going to show up in multiple spots. It's a powerful concept. Does that make sense to everybody? Does anybody have any questions about that? So that right there is why, even though methods do add a layer of complexity to our code, we as programmers are so fond of using them. It does make our lives a lot easier, does help us keep our code more organized. Consider too that, you know, copy pasting something 10 times is going to take up a lot of space. That's a lot more scrolling I have to do. That's a lot more code that I have to look at. Just a lot more stuff. This allows me to keep everything neat. Anytime I see repetition, you can stick that in a method and then just reuse the method over and over again. It's a very nice tool to be able to use. Let's take a look at some more examples. Specifically, I'm going to take a look at another song next. So I'm going to switch down to section 2 here and look at this song. I'm sure you're probably familiar with this song. I've got a 3-year-old and a 5-year-old at home, so seeing nursery rhymes at work is like, I can't take it anymore. But no, I'm kidding. I don't mind. But anyway, Old MacDonald, the classic, right? Think about, you know, every time we change the animal, we have to change the sound that the animal makes as well. And if I wanted to make this code sing this song for a bunch of different animals, it would be kind of tedious, right? I'd have to copy this entire section, and then everywhere it says, you know, make it say cow one time, and then copy it again, and then make it say, you know, duck the next time. Or I can recognize that actually the behavior is largely the same, right? It's just a few values that change. So there's a lot of repetition. There's a lot of commonality, but only the name of the animal and the noise that that animal makes are the things that are actually changing in this song. So I can keep all of that stuff that's the same and then use something called parameters to my method that allow me to tweak the way that that method is going to behave or operate. So with the previous example, our method just did the one thing. That's what you got. You call the method, it does the thing, the end. Parameters allow us to supply some additional information to our methods so that we can now have some control. We can now perform the behavior in a certain way with certain values. So if we look at the case of, you know, Old MacDonald, the parameters are given inside of the parentheses here. In fact, we can actually kind of take a look at the anatomy of this method definition as a whole. We have these 2 words up front, public and static. These 2 words, we're getting closer to being able to describe them. It's going to be a couple more weeks before we deal with public and static in more detail. So for now, you can still kind of treat these as magic words, hocus pocus, that we need to get methods up and running. This we're going to talk about later today. That's called the return type. That's not what I'm talking about right now. I'll talk about it later today. This is the name of the method. And then as the topic that I am talking about right now, these are the parameters. And so parameters look an awful lot like variable declarations, right? I see a type and then a name. So string animal, string noise. Right, so I have 2 parameters here, one for an animal and one for a noise. So if I want to make this work for a cow, this would say cow and this would say moo, right? And then anywhere inside of the method that I see the word animal, you can see that it's just going to plug that parameter in. And anywhere it sees the word noise, it's going to plug that parameter in. These feel, you know, an awful lot like variables. They are basically variables. The only difference between a parameter and a variable is that parameters are specifically used with methods. That's really about it. specifically used to take input to a method. That's what parameters are. But for all other purposes, they're essentially variables. And so now when we call the method, since we have parameters, we have to specify what these are. So when I say, go sing the verse, I have to tell you what animal and what noise it makes. If I don't provide that information, then it won't run. So if you take these parameters out, it'll say, I can't do what you're asking me to. You got to give me more stuff. So it's not optional. The parameters are not optional. They are required. You have to supply them. I think it's interesting to note that, okay, main is a method too, right? Main is a method. It's a very special method, but it follows the same format. Public static up front, return type. This is the name of the method. These are the parameters. We haven't used these parameters for the main method, and actually we won't in this class. If you would like to know what these are for, though, I do get asked this question quite a bit, actually. If any of you are familiar with using the command line on the computer, so when you see, like watch hackers in the movies, hacking on the black screen, right, that kind of deal, you can run Java programs from the command line if you want to. And if you ever find yourself in that situation, this is a way that you can get information from the command line into your Java code. So that's kind of a nice thing to be able to do. We're not going to be doing that in this class, though. If you ever take some upper-level comp sci classes, you may get around to doing that. It is required. That's why we put it there. It's necessary. The computer expects it to be there, so we put it there. But we don't have to use it, and we're not going to. But kind of back to the task at hand, if we think about how these parameters work, I'm going to step through this in the debugger as well. I think it's so important to walk through all of these programs, right? If I start this off in the debugger, here I am on line 22, the very first line of my main method, right? Call stack has the main method. And then if I step into this, over here on the right-hand side, you'll see now my variables window, I've got two variables, one called animal that says cow, one called noise that says moo. Those are my parameters, right? It took the values that I passed in here and basically said string animal equals cow, string noise equals moo. Now go, do the stuff in the method with those values. And so, yeah, you can step through all this stuff and it'll print out the lyrics to Old MacDonald, and it finishes it for the cow, and then it says, okay, now do it again. Except this time we want you to use duck as the animal and quack as the noise. So when I jump up to the verse to run it the second time, right? Take a look at my variables over here. I see animal is equal to duck and noise is equal to quack. And it's going to run through the exact same code that it did with the cow, but since my parameters are different, it's going to sing a different verse of the song. That's great. That's important. That allows me to use the same code and then give parameters to tweak that code to suit many different situations. It's a very, 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 very valuable tool, right? I now have a method that can work for many different situations. Any questions? Yeah?
Do you mind scrolling up because the one on ours is blank?
It is?
It's in the second.
It's in the second one. I'm sorry about that. I switched down to this one right here. Sorry about that. Question?
Yeah, my question is, I just want to confirm that if, like, in this kind of message, we're going to main message the line and set by default, so we will go through the verse, call, null, and duck property first, and then plug them in back to the method of those.
I'm not sure I understand your question. I'm sorry. The main method is where we begin. So we always start here. Maybe what's a little confusing, I mean, the main method can do anything, right? So you've been doing all your assignments in the main method up until this point, right? So I can add whatever I want, for loops, while loops, if statements, all can go in here, right? We're just adding another tool in our toolbox, which is the ability to use methods as well. I don't know if that helps answer your question.
Yeah, I like when
Okay.
method, how could like where could we write or something that we set to let the computer understand that we only want the first line of the verse? Is it something like a
It's not the first line, it's the whole verse.
yeah, I mean like the cow and the moo, the two things that we plug in, the animal and the noise. They're all the
I
first
mean, that's
line.
just how methods work. When I write the method call, it is saying, go do this method and plug this value in for this parameter and plug this value in for this parameter and then run all of these lines of code. That is what a method call is saying to do. That's just how a method call works.
So it doesn't need a for loop or a while loop to go.
No, no. That's what methods do for us. Whenever you see this word pop up with parentheses after it, like we do here, see the name of the method pop up with parentheses after it, that is an instruction telling the computer, go find this section in the code. Go find the method called verse and do that stuff. That's what I want you to do right now.
I understand.
Yeah, it is complicated, so if you are having a hard time understanding the flow of things, I completely understand. Happy to go through more examples. Yeah.
Like, because you declared like string animal, the first string you mentioned is animal.
Correct, and the order does matter. Yes, the animal has to come first. Also notice too that whoops, I did name these. I did name these. String animal and string noise, but like that's the computer's not going to enforce that, right? That's on me. So if I make cows go oink, well, the computer's not going to stop me, right? That's on me. Okay. Let me double back real quick and explain some more info about the debugger. I'm using the debugger a lot because I think it's so important. So let me explain what the difference is between those two yellow arrows is, like I was talking about before. I'm going to restart this program in debug mode. So here I am on the first method call. These two arrows matter when we're dealing with methods. So this arrow on the left is called step into. That means if I click this button, I will actually go up to the top, go up to this method and start working my way through there. Step over says, I'm not actually going to jump up there. Just do it and then move on. So if I click step into, the next line that I end up at would be here because I'm going into the method, right? If I click step over at this point in time, the next line that the debugger is going to take me to is here because I'm saying I don't need to see all the stuff inside of the method. Just do it. Just go. Just do that stuff. And so you might be saying, well, all right, like why would I ever choose to do one over the other? And consider that as we go along, we're going to be writing programs that have a lot of methods in them, many methods, more than just one or two. And some of those methods are going to work just fine. Other methods aren't going to work very well. And we're going to use the debugger to help us understand how our code works and find where the problems are, right? So if I come across a method and I'm like, well, I'm pretty sure that this method is not the problem. I understand how this method works, right? I'm not confused by the code. I don't need to step into this one. I don't need to step into the method and see all the lines one after the other. I already get it. I don't think this is the problem. I don't think this method's broken. I'll just step over that one. And I'll use step into on the methods that I think are where the problems might be or are the areas where I'm unsure of how this method works or what it's doing so that I can use the debugger to look at those in more detail. So that's what those two are for. It's your choice as the programmer, right? Depending on what you need. The debugger is a tool. So if you come to a line of code and you're like, I don't know how this method works, step into. It's a good choice. If you come to a line of code and you're like, I know how this method works, I know what I expect this method to do, then you can choose step over to you'll see that it did still run the method, right? The method still executed. I just didn't step through it line by line. So it's up to you whether you want to see the whole spiel or not, the whole thing or not. Does that make sense? Just another tool in your toolbox. Yeah.
Yeah, so like when we were doing the verse, like we will just directly go another again and plug in the other line, other verse,
Correct.
Yeah, and if we're going step over, so would it just skip the entire method or just go to the other first step?
So it's not skipping anything when you step over. It's just not stepping through it. I'm not stopping, right? I'm not stopping in the middle of the method. I'm just saying go do the whole method and then stop after that. That's the difference. Step into says I want to look at every single line of the method and step through it one at a time. Step over says just run the whole method and then let me know when you're done. That's I hope that clarifies. Yeah. Any other questions that I can address before we move along? All right, so let's write a method because so far we've been looking at code, and it's one thing to be able to look at code and understand how it works. It's a totally different thing to be asked, how do I actually write one of these things? So I'm going to switch to the payroll calculator example. And what we're tasked to do here, we've got 2 employees. You can see down here at the bottom, I've got Fred, and don't worry, this is a very old example. These, anyway, this is how much money they're getting paid per hour and how many hours they worked. And so we want to compute and display, Fred is getting paid such and such, and Amir is getting paid such and such. And we're going to write a method to do this. We don't have to, right? It's not necessary for us to write a method to do this. But I think that for any repeated behaviors, you can imagine that, I'm probably going to have more than just 2 people that I need to compute the pay for, so I could consider using this for a lot of employees. But even still, I want to try and identify any repeated behaviors and give them a name, and then use those methods over and over and over again. So when faced with this task, try and identify, again, the common parts that you have to do and then the differences. The common parts, hopefully, are going to be the actions that need to take place. So I need to do some multiplication, right? It's not a difficult math problem to have to do. It's just some multiplication and then probably like some sort of a print statement that says Fred made whatever. So it's not a tricky amount of work that we're being asked to do. But I can see that there are some differences. The name is going to be different. The hourly rate is going to be different. And the number of hours that the person worked is going to be different. So those differences, those are going to be your parameters. If you've identified a repeated behavior, any differences are going to become parameters. Anything that's similar, that's the action. That's hopefully the behavior of the method itself, the calculation that's taking place. So let's go up to the top and see if we can start to piece this method together. Again, at least for now, this will change in a few weeks once we start talking about this stuff in more detail. But for now, anytime we ask you to write a new method, you can just go ahead and stick in public static automatically as just a little bit of necessary code that we need to get up and running. The next value is the return type. We haven't actually talked about the return type yet. We will. For now, we're going to leave it as void. The next part of our method definition is the name. So they told us what to call the method here, right? They said call this method calculate pay. But that's not always going to be the case. You're going to have to come up with your own names. And so I think, like we talked about with variables, it's important to give descriptive method names as well. Method names should ideally be verbs, should be an action, should be a behavior that's taking place. So calculate pay, that is an action, right? That's a verb. It's a good method name. Always put in the parentheses, always, always, always. If there aren't any parameters, then those will just be empty. That's okay. We don't have to have parameters. I've seen examples of that. In fact, if I'm ever just trying to display information to somebody, print something on the screen or draw something on the screen, then, that's okay. But in this case, we do have parameters. So let's talk about what those parameters are. I can see that the name is changing, and the type of that is probably going to be a string, right? So string name, the hourly rate is changing. I see the decimal there, so that's probably a double. And then the hours are also changing. So I'll include a parameter for that as well. I've got 3 parameters. Again, it's up to me as a programmer to decide how many parameters I have, what the types are, what the names are. Those are all choices that I have to make. But if you have a clear goal in mind, it should not be difficult, right? It should hopefully be straightforward to come up with these. And then also please notice that after I've put the closing parenthesis around my parameters, I almost always forget to talk about this part because it's just so automatic for me. I just stick in those curly braces right afterwards. That's what we would call the body of the method. This is what we want the method to do, right? The actions. So any line of code that we've seen is fair game in here. I know we're keeping things somewhat simple today, but if statements can go in here, while loops can go in here, for loops can go in here. You might see some examples of such things later on, but any valid code can go in here. For our purposes, we don't have a whole lot of complex stuff to do. We just want to compute how much they get paid and then print it out. So let me go ahead and do that real quick. The pay is a simple multiplication, rate times hours, and then I'll say name gets paid pay. So what does the body of my method do? It multiplies the rate by the hours to compute the total pay and then spits out, you know, what it should be. Notice something. I wrote this. Do I know what the value of rate is? Is the value of rate just one thing? It could be anything. It could be anything. It could be any valid double, right? It could be any valid double. So when you're writing code here, it's important to consider how will this work for not just 1250, but also -70. Well, that's a weird value. Can somebody get a negative pay rate? Well, not really. But does the computer know that? Absolutely not. We're not going to solve that problem today, but that is a problem. And it is an important one for us to think about. For now, we'll just assume that we're not going to get any weird numbers in here. I think the more important thing to consider is that we have to write this for any values that we may expect. And consider how this would work for any such values that we might expect. If I run this program now, what's going to happen? Anybody know? There's no what? Yeah, there's no values. So what's going to happen is a whole lot of nothing. Whole lot of nothing. Actually, there's a couple of things you could look at to answer that question. What do I do first? If I'm in a program, what do I do first? Main method. What's in my main method? Nothing. 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 This is a common thing that happens. I wrote this thing. I run my program. Nothing happens. What do you mean nothing happens? I wrote all this code. Why is nothing happening? This is a template. This is a definition. Right? It's a generalization. It's abstract. In order to use it, we have to do what's called a method call. So a method call provides specific values and executes the method. It's a specific execution. So if I come back down here to where it says we need to call the method, the way that we call a method is by typing out the name of the method, oops, putting in parentheses, and then if we have parameters, which in this case we do, we have to stick them inside of the parentheses. So the first one that it asks us for is Fred with an hourly rate of $12.50 and 20 hours worked. So now that I have inserted this method call, if I run this program again now, we can see, all right, now it does tell me Fred got paid $250. It didn't tell me what to do for Amir, though, because I haven't added a method call for Amir. I could very easily do so. And then here's another, I think, hopefully another illustration of why methods are so useful, so valuable. With the method, if I want to do it for somebody else, it's as simple as copying the method call and changing the parameters. Copy pasting can be a problem, but actually doing this, copying a method call and changing the parameter, ooh, I love that as a programmer. That means I've got a very useful method that I can use in many different situations. That is a good thing. I like being able to have code that I can write once and use many, 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 many times. This is a good sign of a nice, well-organized program. Being able to reuse this code. Consider what the alternative would be, right? Would be to copy paste this a couple of times and then have to type the actual values in. That's tedious. That's annoying. It's hard to change. It's hard to update. It's clunkier to work with. And if I ever want to add another employee, I have to copy paste it again and change the values again. And so it can get very cumbersome. Yes? The question was about Scanner. So let's talk about Scanner for a minute. Scanner is how we get information from the keyboard, right? So, can you use Scanner with these? Absolutely, you can. Yeah. You can create a scanner inside of a method and use it to get keyboard information if you want to. Sure. You'll be doing that at some point over the semester. Absolutely. Yep. Any other questions? Yeah. Ah, great question. Can I use an array where?
Like, instead of listing every single employee and their rate, you
Uh-huh. Yes, absolutely. You could use arrays in many spots. So could I create arrays here in main with employee names and hours and stuff? Yeah, absolutely. I probably would still extract those values out of the array, though, and stick them into my method to compute the pay. Does that? No? Does that feel good? Not feel good? Maybe an easier way to step into this would be instead of just having the name Fred here, let's keep arrays out of it for a moment. We can certainly do something like this, right? So if I have a variable that has a name in it, well, I can just plug that variable anywhere I want, and it'll stick that value, and that's okay. So to answer your question, can we use arrays instead? Yeah, absolutely. I can access arrays here. It's all valid. It's all fair game. Yep. What maybe some people don't like to hear, can my parameters be arrays? Yep. Absolutely. Absolutely. You'll actually get some examples doing array practice in Studio. I don't know if I have any on my agenda for today or not. I mean, I can, but I really hope, would really like to drive the point home that this is just a type. This is just a type. So it can be string, it can be int, it can be double, right? It can be Boolean. If I want it to be an array, it is now an array of strings. Not just one string, but an array of strings. Right? It is now an array of ints. So any valid type can go there. And arrays are types. Arrays are types. I know it's complicated though. That is an abstract concept, so I completely understand if your brain is having a tricky time absorbing that information. It'll take a few times for it to sink in, possibly. But yeah, great questions. Great questions. Any other questions before I move on to some other examples? So what gets kind of interesting then is that, all right, I've got different sections of my code now, right, called methods. And those methods are all focused on one task, right? Every method is focused on doing one behavior, one task, and doing it well. And it might need variables to pull that off or parameters to pull that off. But now we have to consider that, okay, this method is going to need a certain set of variables and parameters to do its job, and this method is going to need a certain set of variables and parameters to do its job. And, you know, maybe some of those are kind of the same, and maybe some of those aren't. And how do we keep track of that? How do we keep track of, you know, what variables a method is using, or even what variables a method can use? What variables are even available to be used within a method? Let's talk about something called scope. So scope is the idea, the concept of scope refers to any position, any spot within the code where a variable can be seen. It's said to be that variable's scope. So if I have a variable called x, anywhere that I can access that variable x and the computer does not complain about it, that is that variable x's scope. But we can talk about it in a little bit more detail than that, right? Actually, the scope is defined by these guys right here. Curly braces. Curly braces. So to show you an example of scope, I've set a breakpoint here on line 13, the beginning of this program, and this is just a very simple metric, conversion. I'm not interested in the arithmetic so much as the coding example. Notice over here in the main method, right? I'm in the main method. Very first, I haven't done anything yet. There's no variables. There's no nothing listed over here. I haven't done anything yet. But let's step into this and see. Okay, I now have a value of inches, which is called 10. And it's going to create a variable called centimeters, which is now 25.4. So now I have two variables. Well, I have a parameter in a variable, right? Inches is my parameter. Centimeters is a variable that was created. So I do those things. I print out the value. And now this is done. And I'm going to go back to the main method. But wait a second. When I get back to the main method, if I look over here at my variables window, inches and centimeters are now gone. They don't exist anymore. Furthermore, if I were to come back to the code here and try to, just do something like this, right? Just print out centimeters, right? Just tell me what that, you can see it's immediately complaining. I don't know what you're talking about. Well, wait a second. I created it right up here. What do you mean you don't know what I'm talking about? Well, that's because we are outside of the scope of this variable. We can't see this variable here. We're outside of the scope. How do I know? It's actually fairly simple to figure out. If I create a variable within these curly braces, I can only see this variable within these curly braces. So as soon as I exit this ending curly brace for this method, this variable which I created inside of this method is no longer visible to me. I can't see it anymore. It's not accessible. The scope of this variable is the method. There's one little sort of wrinkle / exception to that rule. This parameter, inches, technically is not within the curly braces, right? It's one line above that in the method declaration, the method definition. But the scope of this is also those curly braces. So the parameters have the same scope as any other variable that is created within the method. If I create a variable within a method, it can only be seen within that method. As soon as I leave that method, I can no longer see that variable. Question in the back. Is there any way to get around it? Well, yes. And we've actually already seen one way, which is to use parameters to pass information into a method. So if I need to access a value from here, up here, what do? I plug it in as a parameter. Or to really illustrate that point, what if I do, this is actually a good example to do anyway. What if I do something like this? Right? So I've created a variable called inches here, Actually, this should be a double, I suppose, shouldn't it? That's a mistake. But anyway, I also have this parameter called inches up here. Are they the same? No. No. They are two separate entities. This one, this copy of inches, only exists within inside of this method, and this only exists within this method. But I have used the parameters to take the value of this one and pass it in. Pass that value in. We can actually see how that works. So if I run this through the debugger again, I can step down until I see my first method call. Here's my variable called inches with the value of 10. As soon as I step into this method, you see, all right, there's my parameter called inches, also with the value of 10. But these are not the same. They are two separate values that happen to have the same name. This is potentially confusing, but let me tweak this example a little bit and hopefully it'll help illustrate what I'm talking about. What if I just change one of these to be a little bit different? Okay, so now I have a parameter up here called inches, but I just abbreviated the name of this one to say in. All right, let's walk this through the debugger again. I'm going to create my variable called in, right? I'm going to step into the method. I no longer see the variable called in. I can't. It does not exist within this scope. It exists within this scope. So how did this value of 10 get here? When I plug the variable into the method call, there's an implied assignment happening. It's taking the value out of this variable and assigning it to this parameter. The computer is behind the scenes quite literally saying inches equals in, and then running the method. Does that make sense? I hope. It's a very important concept. I'm happy to, because I understand that it is confusing, but it's also extremely important, right? I've created a variable here called in. This variable was created inside of the main method, so it can only be seen within the main method. I cannot use the name in anywhere else except within the main method. If I try to, the computer won't know what I'm talking about. It says, huh? There's no variable called in. That doesn't exist up here. It only exists in main. The problem, which I think was being asked about before, is okay, then how do I get information from one place to the other in my code, right? That's important. We have to be able to take information from one section, pass it to another. That's what these method calls are for. That's what the parameters are for. When I pass something in as a parameter, I'm taking the value out of this variable, plugging it into the method. It is now taking that value of 10 and saying double inches is equal to 10. That's what happens when I do a method call. This variable, this parameter is getting created as I start the method. It did not exist before, but I'm going to create it, and I'm going to take whatever this value is and set it to this parameter, and then I'm going to do this stuff. When I come down here to the next line, it's going to do the exact same thing, right? The only difference is that here I had a variable that I was using that had a value of 10, but here I just wrote the number 15.7. They both do exactly the same thing, just a slightly different mechanism. Yes?
This situation is like just like we were equating a variable and it's gonna get to it like it was written inside this method, so it works with this outside, then the one with
I'm not sure that I follow. I'm not assigning anything to the method. I'm assigning values to the parameters. The parameters, remember, these are placeholders. Inches could be 7, could be 2, could be 10, could be 1,000,000. When I call the method, I make a choice. I want it to be 10. It's no longer general. It is now a specific value. I take this value of 10 from the main method and I pass it, physically pass it from the variable in my main method to the parameter of the method that is being called. There are two entities the value is traveling from one to the other. They are not the same thing. They might have the same name. If they do, that's just coincidence. Or honestly, as the programmer, it's your choice. So if you want them to have the same name, then you can. If that's confusing to you, then don't do it. Make them different names. That's your choice. If it'll help you keep track of things better to give everything slightly different names, then do it. I don't have a problem with that. It is confusing though. I do understand that it can be tricky to wrap your brain around it. So does anybody have any questions? Yeah.
So when you have double inches, that just means that later on you can write down a double and employ it, or you can declare double like with the name and use it.
That means in order to use this method, I have to give you a double.
Yeah.
I have to tell you a number. But this is just a template. This is just a placeholder. This tells me what to do for all values of inches, right? When I call them, this does not do anything by itself. It doesn't do anything until I call the method. That's when I plug an actual number in and it does the work. So no work actually takes place, no computations are happening until the method call occurs and I have a specific value upon which to work. Any other questions before we try another one? Maybe the next example will kind of help with the understanding as well, because here, let's take a look at this example. It's a similar setup. You can see that I have a variable called y. This is a very simple squaring method. It just takes in an integer value x and tells me what the square is. You can see there's the multiplication. But what's a little interesting is that, like, okay, I pass in this value of 5. This says x equals x times x. So the question is, does this have an effect on what happens, down here? If I call this method and it changes this to be 25, then when I print out y down here, what's it going to be? Is it going to see the effect of this multiplication or not? Anybody know? Been talking about how values get from one method to the other. There's two separate variables here. There's y and there's x. They are not the same. They are not the same. So any changes that I make to x or any variable, it doesn't matter. Any changes that I make to variables in this method cannot affect variables in this method. It is not possible. Or to really, really, really drive this point home, let me make another little change. Let's make them all called y, right? Everything is called y now. No more x. Oops. No more x. Everything is called y. But I have two variables called y. Or more specifically, I have one variable and one parameter. So when I do this, I am taking the value out of y, the variable. I am passing it into y, the parameter. So when I make changes to y, the parameter, this is a totally separate copy of y. It's not the same y that I was talking about down below. It's a different one. So this y is going to remain unchanged. If y is 5 here, after I do this, y is still going to be 5. And if you don't believe me, you can run it for yourself, or perhaps what might even be more valuable is to, once again, run it through the debugger. You can see there's the square. But let's step through this. My breakpoint is right here on line 13. So first I create my variable called y. I am in the main method. I know I'm in the main method because I see the main method over here on the call stack. Right? If I step into the square, you'll see, all right, now I'm in the square method. I know this because I see square on the call stack and I see, all right, y is 5. If I continue to step, I now will square y, and that will tell me that y is 25. But remember, this version of y is not going to be changed. This is a separate copy of y. You can actually check this for yourself on the call stack. If you click main, it will say, here I am waiting right here on line 14 while you go off and compute the square, and the value of y is very clearly shown here is still being 5, right? Still being 5. This is not the same y that exists in this method. So you can actually click on these over here to look at the variables in each of the different methods. See which variables are in the scope of each method and what their values are. Very useful to be able to do. But continuing on with the example, we print out the square, which is 25, so very clearly y is 25 here. As soon as this method is over, we're going to go back to the main method, but the version of y that exists there is not equal to 25. You can see that it's still very clearly equal to 5. Again, because there's nothing that we can do in this method that is going to affect the variables of the main method. It's not possible. Are there any questions about that? We have a name for this. We call it pass by value. I'm not giving you the actual variable when I plug it in. I'm giving you the value. And then you are manipulating a copy of that within the method. Alrighty. Got one final very important topic to talk about. Any questions though before I switch to the next example? So we've talked about parameters. That's how we get stuff into methods, but we need to get stuff out of our methods as well. So this is a one-way street so far. I can take values from main and feed them into square, but what if I want to get values out of square back into main? We haven't talked about how to do that yet. So parameters allow me to take values and plug them in when I call the method. The last thing we're going to talk about is the return value, the return type. So I'm going to switch to the volume example here. And we're now going to be looking at the word that comes after public static. So I've explained what everything else does, and we're now going to talk about what comes after public static. Let's start with main. So the word void shows up here in the main method. Void means that there is no return value. There is no return type. So the return value is the output. If the method computes something, right, computes a value, computes some piece of data, the return value is a way for the method to say, here it is, here's the thing that I computed, here's the thing that I did, here's the thing that I made. Right? I'm actually going to give you something that is the result of the work that has taken place in that method. If this is listed as void, though, that means that I'm not going to do that. There's no return type, there's nothing coming out. So parameters are how I can have stuff come in. I can leave this empty if I want to. This is how I tell the computer what stuff's going to come out, and I can have this be void if I want to, which means nothing comes out. If I do want to have a return value, then instead of seeing the word void, I'm going to see a type. And it's the same story. This can be double, boolean, int array, both one-dimensional and two-dimensional, or three-dimensional, or million-dimensional. Computer don't care. Does not care. Any valid type will work here. You'll get some practice on using arrays for return types in Studio later on this week. For today, we'll keep it simple. This means that I'm going to give you a single number back, a double. So if we look at what this method is doing, it's saying if you give me a radius and a height of a cylinder, I will take those values and I will give you a double representing what the volume is. And this is about the point in time when I get asked, okay, what's the difference between returning something and just printing something, right? Because weren't we already able to, compute this and show this without having to deal with any of this double void nonsense? And the answer is yeah, we could. This is actually something that I get asked about all the time. It's a very common thing that students can get confused about. Printing and returning are two different things with two different purposes in life. What can often happen is that students will print when they intend to return, right? It's possible to do both. You can do both if you want to. Printing is the act of taking the information and showing it on the screen to somebody. So I'm taking that and just putting it on the screen. Returning is taking information from one part of my program and sending it to another part of my program. So it has nothing to do with seeing it on the screen at all. I don't have to see that information at all to be able to do that. Right? So if I actually want to see what that value is, if I actually want to know what is the content of this variable, print it. That's what printing is for. If I just want to take that value and send it somewhere else, I'm probably talking about input parameters to get information into a method, or return values to get information out of a method. So let's take a look at it in action. If I look at how this main method works down here at the bottom, the very first line looks a little bit different. Here's my method call. There's my method call. You can see I'm plugging in a radius of 4 and a height of 10 for my cylinder. I'm looking at the right-hand side first because I'm doing a variable assignment, and so I'm always going to look at the right-hand side first. So what this line of code is saying is go off and do this method. Then whenever this method is done, it's going to give you back a value. I want you to take that value and store it in this variable. Take that return value and store it in this variable. Notice that the type of this variable is a double, which is the same as the declared return type. That's not a coincidence, right? Has to be that way. That's expected. Those types have to match. If the method's going to give me a double and I want to take that value and store it in a variable, that variable should probably be a double too, right? But let's see if we can kind of understand the difference between returning and printing by walking through this and seeing exactly what happens. Here I am on line 13. Here I am on line 13. It says go off and do the volume cylinder stuff for this radius and this height. So okay, there's the arithmetic. It's not terribly complicated. Return. We haven't seen that word before. I've been saying it all day long, but what it actually means is it's saying this is your answer. Here's your answer. So return the result of this computation. Do this math, and then whatever that result is, that is a double value that I want you to output. I want you to return. Okay. So if I do one more step, you'll see that I have returned. Quite literally, in the sense that this method is over and I went back to wherever I came from, right? I returned to where I came from. How did I do that? How did I know where to go back to? Yeah, but how did you know? Where would you go to look if you were unsure? Where are you going? It's on the screen right now. Call stack. Call stack. Call stack tells me where I've been. So if I'm ever returning, I just go look at the call stack and see what method I was in just prior to now. And that's where I'm going back to, right? Okay, it tells me over here that the method returned 502, so, blah, 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 blah. I'm going to take that value and I'm going to store it in this variable called volume. Notice that nothing has been printed yet, right? Nothing has been printed out yet. But I have successfully returned something. I have successfully taken information from one method and placed it in another. I'm now taking that return value of that variable and printing it out, which is totally fine. Or I could do some more math on it. Or I could pass it into another method if I wanted to, right? I now have a copy of that data here in my main method that I can go on to continue to use, continue to process, do whatever I want with. If I don't have this return value, remember, Scope says that stuff that's created inside of methods does not exist outside of a method. So if I'm not utilizing this return value, I can compute this all I want, but it's just gonna disappear as soon as the method's over, right? Just poof, gone. I might be able to see it on the screen, but I won't have a copy of it in my code anymore. So if I need to do additional computations, I won't be able to access that value. Let me show you what that looks like, actually. Some common things that I see. One of the most common things that I see, actually, when dealing with return types is this. So I just took off the part where I declared the variable. I see students do this all the time. They'll get the idea of method calls, right? They'll say, I'm calling this method. I think it's working right. I think it's doing the math properly, but I can't get the answer. Why isn't it giving me the answer? Where's the answer? Remember, we're returning something. It's actually taking a value and giving it to you, saying, here's the thing you told me to compute. This line of code is saying the equivalent of being like, oh, okay, thanks for that volume you computed. Just throwing it in the trash. If you want to keep something, you have to apply a label to it. You have to give it a name so that the computer can remember what it is. And that's what we use variables for. So I'm actually going to create a variable over here. If I want to store the return value and use it later, I have to create a variable and store that return value in the variable. From here, I can go and do other stuff. I can do more arithmetic with this if I want to. So it gives me the ability to take information and pass it both into methods and out of methods. This is how methods communicate. This is how methods communicate. If you ever type the name of a variable and you can't access it because it's in another method, well, maybe that should be a return then. Maybe you should return that value out of the method so you can access it that way. That's what return values are supposed to be for. I want to talk about a few other things regarding return statements to kind of wrap up with the few minutes that I have left. Let me make a little tweak here. So I can show you some other things that I see students do when they're writing methods for the first time. So I made a little change to this method. I said, I just made a variable, right? And then said, return this variable. It should work exactly the same way. I just split it up a little bit, made it a little bit longer. In fact, right, you can do as much as you want up here. I can make variables up here. So like I was talking about earlier, I can do whatever I want inside of these methods. If statements, while loops, that's all fair game. Once I hit the return statement, however, that method is over. It's done. It's not going to do anything else after that. The return statement, when I say return, I am telling the computer that I am finished. I've done all the work that I need to do in this method, and this is the result. This is the output. This is the answer, whatever this thing happens to be. So what I'll see students do is maybe stuff like this, where they'll say return answer and then come down here and try to do more stuff. And you can see that the computer is like a little bit confused with me right now. The computer, again, sees the word return and thinks, I'm done. The method is over. I'm going to literally go back, literally return to wherever I was before. So when it sees stuff down here, it's like, huh? How am I ever going to do this? How am I ever going to get here? You're telling me right here that this is over. So why is there more stuff down here if this is over? If you hover over this, it'll actually say, unreachable code. You're wasting your time. I'm never going to do this. This code cannot and will not ever be executed because the return statement is the end. The end. So think about, okay, let's try some other stuff. Let's try some other ideas. I can do stuff like if, blah, 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 then return something. Return statement within an if statement. That's cool. That's doable. But another thing to keep in mind is that if I've specified that a method has to return something, then it has to return something, always. So what happens if this is false? What do I return if this is false? I can't leave that question unanswered. The computer is going to look at this and say, I have to know what the answer is for any possible path that I can take through this method. So if this is false, I have to have a return value down here as well to tell you what the answer is if it's false. That opens up a whole host of other things. Notice I can have more than one return statement in a method. That's okay. I think if you do that, it's pretty much a guarantee one of them is going to be in an if statement, right? Definitely doable. Let's think of another example. Let's talk about our good friends loops, right? Can we do return, I can do all this stuff. Can I do return statements in loops? The answer is yes, absolutely. You can put return statements in loops. How many times is this loop going to run? Once. Not a very good loop. Not a very effective use of using loops for repetition. Why will it only run once? Because whatever I do here, as soon as I hit return, again, I'm saying this method is over. It's done. I don't care if you're in the middle of a loop. I'm getting out of here. I'm going back to wherever I was before. So can I put a return statement in a loop? I can. In fact, it's not even that unusual to do, but if I do, I bet it's probably going to be within an if statement, so that I'm not going to execute it every time through the loop. I'm only going to execute it in certain situations. That way my loop still has the ability to repeat if it needs to. And again, as you can see, methods do really kind of step up the complexity in terms of the control flow, control execution of the code. The best recommendation that I have for you is to, of course, make sure you understand for yourself, walk through things in the debugger if you're ever unsure. Use that call stack as a reference, and just trace through as many examples as you can until you get it. That's got to be the most important thing, I think, this entire week, is just learning how this affects the flow. We're no longer going top to bottom. We're going to be jumping around all over the place, but it does follow a consistent set of rules. So if you understand what those rules are, you can trace your path through any program that we give you, no matter how complicated it is. You just got to understand those rules. It's tricky though. It's confusing. It's complex. So please let me know if you have any questions. Come on into my office. I'd be happy to go through any of these examples for you. And have a great week. I'll see you later this week in studio, okay? Thanks, everyone.